Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the surface modification techniques. And now we have started the third category of the surface modification techniques, wherein a layer of the suitable material at the surface is developed for improving the surface properties, so that the required tribological life of the component can be achieved. In this category, basically we have the two broad group of the surface modification techniques, where surface layer is developed either using the welding or thermal spray based processes. So, using both these processes, comparatively thick layer ranging from 10 to tens of thousands of micrometer is developed. Like the welding is used for the claddings and the layers of the thickness greater than 1 mm or 1000 micrometer, while the coating is normally used for lower thicknesses like 10 to 1000 micrometer. So, whatever layer of the suitable material is being developed, so the first thing is that we have one substrate material which is not having the required set of the properties, and layer of the material and the material which is having the required properties is applied at the surface. So, now there are various issues when they are applied either using the welding or by the thermal spray process. They will be going through the application of heat. So, heat in case of the welding, basically heat can be applied using the gas flame or using the arc or using the laser or electron beam. In all these cases, purpose of these heat sources is to realize the melting of the material which is to be applied onto the substrate, and at the same time partial melting of the substrate. So, this is so in this case, for better understanding, if a material for surfacing is to be applied by the welding, then the material will be melted. At the same time, little bit melting of the base metal is also required, so that the good metallurgical bond between the material applied and the substrate can be realized. But when this is achieved, when the melting is achieved, what we see that we have molten metal of the material which is to be applied at the substrate, as well as the molten metal is also there of the substrate material, and then intermixing will be leading to the development of a layer of the required properties. So, this molten metal at high temperature will be very sensitive and very reactive with the atmospheric gases. So, it will tend to form their oxides, nitrites, or even the gases will get dissolved in the molten metal, leading to the pores or pinholes in the layer which is being built up. So, this is one aspect related with the application of heat in the welding based method, where heat applied melts, and when the material is in molten state, it reacts with the atmospheric gases, and subsequently so to avoid these interactions of the molten metal with the atmospheric gases, we need proper protection, so that the formation of oxide, nitrites, as well as pores and inclusions can be reduced. There is another aspect, this metal which has been brought to the molten state and intermixed layer in the molten state is available, that will be solidifying. So, solidification of the molten layer is the another aspect that will be governing the kind of properties of the modified surface layer which will be achieving, and which in turn will be affecting its mechanical as well as tribological properties. So, basically there are two things, one is like interaction of the molten metal with the gases all around during the surface modification, and the second is the solidification of the molten metal during the surface modification by welding based approach. At the same time, some of the heat which is being applied during the welding for surface modification, either using gas flame or arc or laser, some of the heat is also transferred to the underlying base metal, and that is why especially in case of the hardenable metals, it forms a heat affected zone. So, if the material is really hardenable, then it can tend to get hardened, and this hardened layer may show the cracking tendency. So, these are other undesirable effects as far as surface modification using the welding is concerned. Now, we will see the another approach of the surface modification using the thermal spraying. So, whatever is the type of the heat source we are using, whether it is the flame or arc. So, this we can say as heat source. So, here we are having the heat either from the flame or from the arc, or any other source is being used. So, here the material to be applied onto the surface is brought to the molten or partially molten state, and then it is accelerated towards the substrate using the suitable means. It may be high velocity jet, and then these molten or semi molten particles, when impinge, they get flattened after the impingement with the substrate surface, and then they will be getting solidified. So, this is how a layer of the material required to be applied on the substrate is developed in case of the thermal spray process. In thermal spray, if we are using the gas combustion, then the rate of the amount of heat which will be transferred to the substrate will be less as compared to the case when some kind of arc is used, because the cooling rate of the coatings and the cooling rate of which is experienced by the metal which is solidifying is very crucial from the performance of the modified surface layers is concerned. So, in thermal spraying, after the solidification we will be getting the layer of the required material, but here we see this is the this substrate is in the solid state, and molten or semi molten particles are impinging with the substrate, and then after getting flattening they will be solidified. So, some kind of the bond is created between the substrate and these solidified splats which are being formed and getting deposited on the surface of the substrate. So, eventually when we get the sufficient thickness of this layer which is being developed, we get a coating of the required material on the substrate, and that is why bonding between the coating and the substrate becomes crucial, because there is no fusion of the substrate, and the molten or partially melted material is impinging, and after impingement it is getting flattened and getting solidified. So, the bond between them is actually relatively poor, because mostly in the initial stage it is the mechanical interlocking, and then little bit metallurgical bond is created due to the diffusion. But the bond between the coating and the substrate, in this particular case, this bond is somewhat poor. So, the bonding becomes one important parameter with regard to the performance of such kind of the coatings. If the bond is poor, then there will be tendency of the separation or removal of coatings from the substrates. In those processes where the melting of the substrate takes place, like the plasma transferred arc spraying. So, there heat being applied is too much, leads to the melting of the thin layer of the substrate, and in those cases the bonding between the coating and the substrate becomes extremely good because of the presence of the very good metallurgical bond. So, this is one aspect. Since the melting normally, if the melting of the material being applied in form of the coating over the substrate using thermal spray process is being achieved under the normal ambient condition, then there will definitely be possibility for interaction of the molten metal of these particles with the atmospheric gases, and so there will be possibility for formation of the inclusions as well as possibility for the presence of the pores between the different particles which are getting deposited, different layers which are being deposited over the surface of the substrate. So, the thermal spread coatings basically suffer from the porosity, inclusions, and the bond strength. So, these are the common things which are there, and if the cooling rate being experienced by the material being deposited is very low, then we may get very coarse grain structure as well, and these characteristics will be lowering the mechanical properties and will be reducing their tribological performance of such kind of the coatings. So, if we see both these approaches of the surface modification, where either we are using welding or we are using thermal spraying, in both the cases the material to be applied is brought to the molten state, and the molten metal interacts with the atmospheric gases, and subsequently its solidification leads to the development of the required modified surface layer, and that is why the performance of such kind of the coatings or claddings in this kind of surface modification approach is primarily influenced by the two aspects. One is the soundness of the layer being built up, which we may see in terms of the presence of inclusions, pores, bonding, or cracks at the surface in the coating which is being developed, and this is happening due to the primarily interaction primarily due to the inherent nature of the process itself. What are the factors that govern these aspects? About that we will be talking later. And another aspect is, during the surface modification using either welding or the thermal spraying, what kind of the degradation in the quality of the material being used for surface modification. So, sometimes if the process is not good, then it can lead to the degradation in quality of the material, and this may happen in form of the loss of alloying elements from the material which is being applied itself, or there can be change in composition of the material itself, and this can happen due to the dilution, or loss of alloying elements can be due to the oxidation of the elements due to interaction with the atmospheric gases like oxygen and the nitrogen. Now, we will see the things in a little bit finer details, like the formation of inclusions, pores, bonding. There are different factors which affect the soundness, and there are different factors which affect the grid, which determine or dictate the degradation in the quality of the material during the surface modification, either in form of loss of alloying elements or the dilution, or it can be also in terms of the way by which solidification takes place. So, the degradation is a very big point as far as the quality of the surface layer is concerned. Degradation in the quality of the material being applied for the surface modification, and this will be influenced by the two aspects. One is how effective protection is being given to the molten metal, how effective protection to the molten metal either in form of weld pool or during the spraying is being given. Protection to the molten metal during the process is being given, like if it is being carried out in the air or in the vacuum or in the controlled atmosphere like argon or helium. So, as per the kind of the environmental conditions in which a spray is being carried out, that will be affecting the kind of interactions between the molten metal and the surrounding environment. So, if the air is present, then certainly the quality will be poor as compared to the case when the vacuum is there and when the inert atmosphere is used during the spraying. So, if very good control over the environment is being maintained, there is no and the molten metal is being well protected from the adverse interactions or undesirable interactions between the molten metal and the atmospheric gases due to the presence of the inert gases or vacuum, then it will be leading to the reduction or absence of the inclusions or pores. So, these in turn will be increasing the soundness and the quality of the surface modified layers. And then another aspect is how much heat is being used, heat input for surface modification is being used, and this in turn depends upon the energy density associated with the process which is being used for the surface modification. So, if heat input is less, for given surface modification, then quality will be better. There will be less degradation in the quality of the material as compared to the case when the high heat input is used, and this primarily happens due to the because the higher heat input will be leading to the increased dilution and increased solidification time, which will be leading to the increased coarse grain structure, and these factors in turn will be degrading the quality of the material layer which is being applied on for the surface modification. So, the protection of the molten metal as well as the heat input being used for surface modification, these are the two big points as far as the quality degradation and quality of the material being applied during the surface modification is concerned. So, we need to consider both these aspects when we are looking behind the surface modification using the welding or the thermal spray based processes. Now, we will see some other aspects like protection. So, as we have seen, the protection and the heat input are the two big points which will be affecting the quality of the layer which is being developed. So, as far as protection is concerned, in the different processes like gas welding, there is no protection, or we can use the flux for removing the impurities if they are being formed as far as the gas welding is concerned. In shielded metal arc welding, for protecting the molten metal, we use the inactive gas environment or envelope which is created due to the combustion of the coating plus the slag cover which is formed. So, this will be protecting. Protection is poor, but still this is the approach for protecting the molten metal from interaction with the atmospheric gases. And then we have like the gas metal arc welding, where we can use helium, we can use carbon dioxide, we can use argon. So, these will be protecting the cover of these gases during the welding, will be protecting the molten metal from the interactions with the atmospheric gases, and the same is true for the gas tungsten arc welding and the plasma arc welding. So, the inert or inactive gases are used basically in case of these two processes, gas tungsten arc welding and the plasma arc welding. We primarily use helium or argon, not the CO2, for protection of the weld pool to avoid the contamination and adverse effects related with the interaction of the molten pool with the atmospheric gases. And then in case of the electron beam, vacuum is used. So, that is very good, it will not allow the interaction of the molten metal with the any gas because of the vacuum. And then the laser, which is now which can be carried out either in ambient condition or in the inert atmosphere using the argon or helium as a shielding gas. So, these are the different approach, different things which are used for protecting the molten metal during the development of the modified surface layers through the weld surfacing for the purpose of protecting the molten metal from the atmospheric gases, so that undesirable interactions between the molten metal and those gases can be reduced. Now, we will see there is another aspect. So, obviously, if you have just a general look about the different the kind of cleanliness which is offered by the different processes. Here in x axis we have nitrogen and oxygen in y axis, and if we see the gas tungsten arc welding process offers the minimum concentration of the oxygen and nitrogen. Then we have the gas metal arc welding. So, GTA welding process, GMA welding process, and then we have shielded submerged arc welding process, SAW, and shielded metal arc welding process is here, SMAW process. So, if we compare, then GTAW and PAW will be offering the minimum concentration, minimum oxygen and nitrogen in the weld metal. So, the cleanest weld claddings will be offered by the GTAW process and PAW processes, while the gas metal arc welding process will be offering somewhat greater oxygen, similarly with the submerged arc welding process. And greater is the oxygen, greater will be the possibility for interactions with the molten metal, and which will be increasing the possibility for the inclusions as well as the porosity in the weld in the modified surface layer in form of the weld surfacing. Now, we will see the another aspect related with the heat input. In case of the heat input, whenever any source of the heat is applied onto the substrate for facilitating the melting. So, the every material or the substrate material will have one latent heat. So, that heat must be applied for facilitating the fusion. Since these most of the metals are good conductors of the heat as well. So, whenever heat is applied, heat is transferred to the underlying metal as well. So, if the energy density associated with the heat source or by a welding process is low, then the heat to be supplied for facilitating the fusion, that will be more, because in low energy density process will require longer time to deliver the required amount of heat, so that the fusion can be facilitated, and therefore we need to provide more heat. So, when the low energy density process is used, we normally require more heat for fusion as compared to the case when the high energy density process is used. In a high energy density process, a lot of heat is applied in very less time, so that the fusion is facilitated, and so in using the less heat itself, and less heat is sufficient for ensuring the fusion of the substrate, so that the weld surfacing can be realized. So, low energy density processes, given amount of heat takes longer, and that is why more heat, and high energy density processes, for given amount of heat it takes short time. So, actually it requires less heat, because the heat dissipation to the substrate is reduced, and we know that when the heat input or heat amount supplied is reduced, then this reduces the volume of the substrate melted. This increases the cooling rate experienced by the substrate during the solidification, and increase in cooling rate. So, all those processes which are higher energy density, they will be leading to the higher cooling rate during the solidification of the molten metal, and higher cooling rate will be leading to the fine grain structure. Fine grain structure, and fine grain structure improves the mechanical properties, improves the tribological properties. So, those processes which are high energy density processes, for the same material, they offer the better quality of the modified surfaces, even through the weld surfacing. So, if we have the laser, an electron beam, plasma arc, gas welding, all are of the different energy densities, and that is why they offer the different kind of the qualities. So, each process differs in terms of the protection, in terms of the energy density, and that is why they offer the different qualities of the modified surface layers through the weld surfacing. About other aspects related with the thermal spring, I will be talking in the subsequent presentations. Now, I will summarize this presentation. Basically, I have talked about the fundamental aspects related to the surface modification using the weld surfacing and thermal spring, and we have seen that the quality of the material being applied is significantly affected by the protection during the surface modification and the heat input which is being given for the surface modification. So, if the protection is good and the heat input is less, then we will be getting the good quality modified surface layers through the thermal spring and through the weld surfacing. Thank you for your attention.